First, I will talk about the introduction to the laser cutting. A powerful laser beam are used to cut, melt, or burn a sheet of material in high precision CNC thermotechnique, which are known as laser cutting. Laser also known as light amplification by stimulated emission of radiation. Customized laser cutter can remove any material out of there are different thickness with accurate parameters and work quickly. Therefore, the laser cutting process are suitable for several materials such as metals, wood, and polymers. Next is three types of laser cutters. There are three types, which is carbon dioxide laser, fiber laser, and crystal laser. As for the carbon dioxide laser, it is a gas mixture of carbon dioxide, helium, and nitrogen. And the wavelength emits are 10.6 micrometer, and the thickness removed are more than 5 millimeter. And second is the fiber laser. It is a series of laser diodes that produce a fiber laser beam. The laser beam will increase as it moves through the fiberglass, and the wavelength it emits are 1.07 micrometer, and it is easy to maintain since it does not have many moving parts for glass circulation or mirrors in the light source. And lastly, is the crystal laser. It is made from the mixture of yttrium orthovanadate (YVO) and lithium aluminum garnet (YAG), and it is can cut thicker materials such as plastics, metals, and ceramics. And lastly, the crystal laser will emit small wavelength, which is 1.06 micrometer. It helps to improve focus, thus increase concentration, and will damage the machine parts quickly, thus increase the operation cost.
When light particles with the same wavelength exit the laser resonator in the same direction, they form the laser beam. In the case of CO2 laser, this beam may be the invisible infrared region of the spectrum, or it may be of different wavelength depending on the application. It may have a diameter of about 0.75 inches when it leaves. Then, one or more mirrors reflect this parallel light wave back into the focusing head. The beam travels through a number of lenses inside the focusing head after entering it. Naturally, this gives it focus. It then emerges from a nozzle and scorches anything it touches. A laser beam focused by a lens produces a remarkably strong single point of light. This powerful light instantly melts or vaporizes the material where it strikes. The proper selection of the laser and workpiece parameters determines the laser cutting process and cut quality. Cutting quality deficiency may be related to the slow process drifts and disturbance brought on by changes in power and spatial intensity distribution, as well as perturbations to optical integrity. There is a lot of research being done on laser cutting to improve the cut quality. Numerous control variables or parameters including nozzle misalignment, cutting speed, and focal position affects the quality of the cut. In addition to working on a wide variety of methods, laser cutting is a tool that can be used in a variety of industries. Compared to machining, laser cutter can produce cuts that are cleaner and more precise. A laser cutter can automatically produce a large number of metal parts for cars, computers, and other devices because it can be programmed and directed by a computer, just like machining. Laser cutting involves numerous different operations of metals. Frequently, unusual shapes like outer frames or hydrofoam parts require laser cutting, as do many components in the aerospace sector. Results are frequently better than those of plasma cutting.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Sharifan Huda. So today I would like to present to you about the effect of the parameter involved in laser cutting. The most common parameter effect besides power and energy is nozzle misalignment. Nozzle misalignment may cause poor cutting quality as the process is extremely susceptible to any discrepancy in the alignment of the cutting gas jet with the laser beam. However, nozzle and laser beam misalignment leads to an overall directional gas flow across the top of the cut zone, which can lead to unwanted cut edge burning. So for the next effect is affected by cutting speed. A reduction in cutting speed when cutting thicker metal cutting thicker materials leads to an increase in the wasted energy and the process becomes less efficient. Other than that, the cutting speed must be balanced with the gas flow rate and the power. As cutting speed increases, striation on the cut edge become more prominent. Jaws is more likely to remain on the underside and the penetration is lost. For example, when oxygen is applied in mild steel cutting, too low cutting speed result in excessive burning of the cut edge, which degrades the edge quality and increases the width of the heat affected zone, HAZ. In general, the cutting speed for a material is inversely proportional to its thickness. The speed must be reduced when cutting sharp corner with a corresponding reduction in beam power to avoid burning. So for the last effect is the effect of focal position. The focal position has to be controlled in order to ensure optimum cutting performance. Differences in material thickness may also require focus alteration and variation in laser beam shape. However, the optimum position is closer to the lower surface of the plate when using inert gas because a wider curve is produced that allows a larger part of the gas flow to penetrate the curve and eject molten material. Larger nozzle diameter are used in inert gas cutting. If the focal plane is positioned too high relative to the workpiece surface or too far below the surface, the curve width and recast layer thickness increase to a point at which the power density falls below that required for cutting. That's all from me, and I will pass the next point to the other member. Thank you.
Hi, my name is Muhammad Faris bin Sobri, and now I'm gonna be presenting to you the advantages and the limitations of laser cutting process. Okay, for the advantages, firstly, the advantage of the laser cutting process is higher accuracy and precision cuts. Using an incredibly small, highly potent lasers, laser cutting precisely targets a concentrated beam of light at substance being cut, with average tolerances of 0.003 mm to 0.006 mm. In most applications, the potent laser melts and evaporates material with unmatched accuracy. In contrast, certain die cutting machines have tolerances as high as 1 to 2 millimeters or more, while plasma cutters typically has a tolerances of roughly 0.02. Laser cutters are almost usually the best option when exceptionally high accuracy and precision are required. One of the reasons laser cutting is so popular in the aerospace industry, where tolerances are so strict because of this. Okay, for the next advantage is lower cost. One of the best advantages of a laser cutter is that laser cutting is affordable, even for a small scale applications. This is so that no special tools that need to be constructed or changed for your project are used when using a laser cutter. Additionally, it lacks mechanical cutting surfaces that degrade over time. All you need for a laser cutting component or part is a material to cut, a laser cutter, and a computer loadable schematic. Even for small batch projects, this lowers total cost, especially when compared to conventional tooling and manufacturing. Additionally, because laser tools have fewer mechanical moving parts, they require less upkeep and operation, which keeps the cost of hiring a laser cutting service lower. Next, a laser cutter can handle jobs of almost any complexity. A laser cutter can handle any task, no matter how complex it may be. Relatively little distortion or warping of the material is caused by the high-powered laser while working on a very tiny piece of it. A laser cutter may be utilized to produce even rapidly and efficiently the most extremely complicated shapes and cuts with unmatched precision and outstanding tolerance levels with the right schematic. So for the next advantage, each laser cutter have higher sheet utilization with less waste. The ability to use a very high proportion of your sheet material is another advantage of the accuracy and precision of laser cutting. A laser cutter can get the most usable components and parts out of any given sheet of material by strategically nested cuts. Once more, this results in cheaper project costs overall and a quicker turnaround. Less time is required to switch out new sheets of material, and the machining and cutting processes squander less of your raw materials. Next, for the advantage of the laser cutting process, it consumes lower power consumption. Contrary to presses and some of other cutting tools which demand vast amounts of energy to deliver cutting force using a physical die, laser cutters have no other moving parts, even though the laser used to cut materials take quite a bit of energy. When used fully, a turret punch, for instance, can use up to 36 kilowatts of electricity. In contrast, even when cutting highly thick reflective materials like aluminum, laser cutters rarely use more than 10 kilowatts of energy. As a result, both the overall operating costs and environmental effect of laser cutting equipment are reduced. As for the limitations of laser cutting process, firstly, it highly required need of expertise. As we've already mentioned, a skilled operator is necessary to unlock the full power of a laser cutter. The proper configuration ensures that the cutting quality meets the standard that people have come to expect from this technology. Second, the limitations to metal thickness. When compared to other thermal cutting techniques, a laser cutting is not appropriate for cutting particularly thick plates. The largest suitable thickness is determined by the equipment and knowledge at hand. Metal manufacturing businesses typically use lasers to cut metal up to 15 or 20 mm. As for the next one, it needs a high upfront cost. The cost of a laser cutting machine might exceed $1 million. When compared to waterjet or plasma cutters, the cost of lasers can be double. Even when the long-term savings from efficiency and operational costs more than make up for it, the initial expenditure is still high. As for the last limitations of laser cutting process, it produces dangerous fumes. The capacity of laser cutting to cut a variety of materials is one of its benefits. The thermal cutting technique simultaneously causes material to melt, producing harmful fumes and release gas. When cutting plastic, this rings particularly true. As a result, a robust ventilation system, which is frequently expensive, is necessary for a workplace that is safe. So that's all for me. Thank you.